So we're here today to talk about webhook architecture. We've been getting a lot of questions and interest in terms of what kind of the best practices around designing a webhook architecture at scale.
Yeah, no,
So
I'm
Tom,
excited to
like
talk
you
about
wanna,
it. Yeah.
yeah. So you want to go through? We have a diagram that we've put together for Svix. We think this is kind of the baseline that people should be looking at. And generally speaking, Tom, like what are the things that you're optimizing for in the design?
Oh, there's a lot. First of all, I mean, you have to think about scalability. Even, I'm going to talk about Svix as a service, but really it all applies even if you're running your own internal webhook service. And you need to care about scalability because, you're going to be churning out a lot of webhooks and you want to make sure that your systems don't crash. You also want to think about security. Webhooks come with like unique security implications. And there's the whole idea behind, developer experience or customer experience. Your customers need to be able to see what's going on with the webhooks, like where they sent, why did they fail, and they have to manage, like add URLs, be able to filter by event types. Just so much that goes into it. At the end of the day, webhooks are just HTTP requests, so it's easy to think that this is all you need, just like one curl command, but actually there's so much more to it. Like there's always is when you run like production environments.
Yeah. Okay. So you want to just take a look at the diagram now, kind of go through like the different components that we have built out, kind of like what each kind of component is for and how they interact with each other.
Yeah, let's do that. So okay, cool. When you look at the diagram, you can see, the big, the big blue rectangle. That's essentially what Svix does. But again, if you build it on your own, it's gonna be your own internal webhook service that essentially does all of that, give or take. I'm gonna talk about Svix, but almost everything applies for if you build your own. So the first thing that you need to take care of or have is an API server. So essentially like a way to get your webhook request. So I want to send a webhook into this webhook sending mechanism. It could be like using a queue or using like literally an HTTP server, which we have, or like whatever you want. You most likely want a load balancer in front of that, just because you want to be able to scale with your usage. But probably if you're just starting out and you're only sending like a small number of webhooks a month, it's not that big of a deal. We also have a WAF, so like a web application firewall, just for like an added layer of security. But that's up to you.
Yes. Can I ask a quick question there?
Yeah, go
It's
ahead.
like if I'm like a software provider, I already have like an API service. Is that something that I would already kind of have in place?
Yes and no. So
Mhm.
yes, but this would probably be like an internal API. So if you have a lot of microservices, this will look familiar. This will just be like one of your microservices.
Gotcha. So be kind of like its own piece.
Yeah, exactly.
Gotcha.
So as an internal Svix, essentially, that's what you do.
Makes
Cool.
sense.
So yeah, so let me just like continue going through the doc. So through the diagram. So first you have the API servers. Again, they get this request, they interact with the database. They decide, oh, does this like a request is even allowed? Is it allowed? Should it be sent anywhere? Should it be filtered, etc. And part of it is like the webhook delivery service essentially, kind of like decide what you want to do with the webhook. The first thing you need to do when you get it is to persist it, because you never want to lose a message. Again, whether you're an external service like us or an internal microservice, you want to make sure that you're eternally reliable there. One of the challenges about webhooks compared to like a normal API is that the normal API is very much constrained within the HTTP request. You make a request, something happens, and there's a response. And if that request dies for whatever reason, it's all good, because the client, the one making the API call, will know that it failed and will know what to do with it. But with the webhook service, they don't know that they expect a request. So you kind of like need to make sure, have like this extra layer of reliability. So first thing you do, as I said, once you first of all persist it to a storage layer. Once you've decided that you want to send the webhook, you can add the task to a queue. And then that you have like a bunch of workers that will read from that queue. The reason why, I mean, there are like a lot of reasons, but like one of the main reasons, or one of the most naive ways to do a webhook implementation is just to make that HTTP call directly from that, like API receiver that we talked about. The reason why you don't want the webhook delivery service to make HTTP calls directly to customers is that customer endpoints may fail, may time out, may take a long time to respond, and you don't want to occupy your API, your API endpoints just like waiting on those and just like killing all the resources there. So it's best practice to put it in the queue and just like background workers to deal with all of that, and make sure that things go as expected. And even if they're like preoccupied, or even they're overloaded, your API endpoints will still be able to listen to requests and get more stuff onto the queue. That's the main thing with that. Obviously, the webhook dispatcher also needs to persist the status, so like what happened, what was the response status code, and write it back to storage. If for whatever reason that request fails, it will want to requeue it. We have an exponentially increasing retry schedule. So you try immediately, and then after 5 seconds, and then after 5 minutes, and after 30 minutes, etc., up to like 2 days in our case, but you can do whatever you want, and essentially giving those endpoints enough time to recover in case something goes wrong. So there could be your customers have like like a 3-hour downtime. That's okay, because the webhook is gonna be retried and retried over again. If you look at the bottom, there's like a caching layer. I mean, we use Redis among other things, but Redis is great. And caching is always helpful, but I think it's extra important for like a webhook service, because you're going to be sending a lot of webhooks and you're going to be hitting the database quite a lot, and it's very easy to succumb to the load. So caching is paramount. And then at the bottom, you see like logging and monitoring. So, we talked about a queue, we talked about loads, we talked about like things being slow. All of this needs to be monitored, because like when you have a queue, the queue can maybe grow to infinity, or can maybe have like significant delays. You need to make sure that, things actually like get processed from the queue, that you need to make sure that the workers work and scale and all of that. So you really need a lot of monitoring on top of all of that. Monitoring that is different to API calls, because as I said, with an HTTP request, it's kind of like everything is constrained. It's going to be like everything that is interesting happens within the bounds of that request. While with, the webhook, it's kind of like everything happens asynchronously in the background.
So to clarify on that, you're essentially saying it's like, because the webhook communication is effectively one way, right? If I send and the customer doesn't get something, they don't really know that something was sent to them and they didn't get it. And so the logging and monitoring is a way for the users, and also for yourself, I guess, to see like, okay, like what's failing and where.
Yeah, so I was actually, this is a great point about the, like not knowing about failure, because as I said, like, you want to monitor your API anyway, but even if you mess up and like you don't have great monitoring, your customers are probably going to let you know, like, hey, your API stopped working. You're going to get visibility into that. But with webhooks, it's very much hidden. Like, it's hard to know that things fail. It takes like more time to realize that things fail. So you need the extra monitoring on your end to make sure that really you got everything covered and your systems are green and everything works. And what I was going to touch on just now is that, and this is like the top left corner of the diagram, is that you want to give your customers visibility into the delivery status. Because as you said, it's one way, like, your server is letting their server know. They have no idea they're expecting a message, right? So they need to be able to have visibility into like what's going on, like what are things failing, where are they failing, why are they failing? Was it like just the internet is being crazy today, or is it something on their end or something on your end? And it's just this visibility makes their life much easier, and also your customer success or support staff will really appreciate it, to have all of this information available for them before they even need to reach out.
Okay, so there's like a component of your customers need to be able to see what's wrong, but then there's also this extra component of you need to figure out if something's wrong yourself because your customers aren't going to be able to tell you.
Yeah, exactly.
Gotcha. Okay.
Exactly that. And one thing that, so we kind of like touched on the basic part of the system. And now we can touch a bit more like about the security aspects of it. So first of all, as you can see from the orange square, everything is in a VPC. First of all, that's just like, best practice, just like compartmentalize stuff that should be interaction with other stuff to their own VPC. But also, like having the webhook system use its own database rather than the main database is often a good idea, because as I said, like the webhook system can cause a lot of load and you don't want it to affecting your main systems. Like GitHub was down a few times in the last couple of months, and it was partially because of the webhook system. So like their solution was to just kill or throttle webhooks for like extended periods of time. And you don't want that happening to you. So just like segment it and make sure that, this can scale on its own and it doesn't affect like other systems. And now, so it's its own VPC, and that's great. And another thing that's important, because webhooks are essentially like a HTTP request from an entity to another entity. But this HTTP request is unauthenticated. There's no way to know where it came from. So the common way to secure that is to sign the requests. And sorry. And essentially, like most webhook implementation, they sign the request one way or another. You need to use a different key per endpoint. You don't ever want to reuse cryptographic keys. Usually you sign it using HMAC SHA-256. Some people use asymmetric encryption, but that's a bad idea for performance. And yeah, I mean, one common pitfall here is that people use insecure hash functions like MD5 or SHA-1, or sometimes they even use like secure hash functions like SHA-256, but they forget to verify the whole thing. So like forget to verify the timestamp. So they're susceptible to replay attacks, or they don't use the HMAC, so they're susceptible to length extension attack. Oh god, I forgot the name. The one when this is like the reason why HMAC exists is like a concatenating two strings and a hash is like not a good idea. I think it's called length extension. Okay. One other common security issue with webhooks is called server-side request forgery, or SSRF. Essentially, the problem there is that webhooks, are HTTP calls that originate from within your VPC, so your private network, and they hit attacker-controlled addresses. So normally, the URLs would be api.example.com, and that will hit somewhere, on the internet. But oftentimes, or an attacker can abuse this and just have it pointing to an internal service. So instead of calling an HTTP request to their servers, they can just say, well, make an HTTP request to the internal HR system or whatever, like other like internal system, and do reconnaissance or even data exfiltration of, directly from using this mechanism. So what you want to do two things, or like at least, maybe more things even, but just like have multiple layers of security. So one thing that we do, it's recommended to use like a proxy. That proxy just like filters and checks like the DNS of the request it's going to make, and just make sure that the DNS is in the allow list, or at least it's not in the disallow list. Like it doesn't hit any internal subnets or any internal IPs. And the other thing is just like, again, for sanity, just put it in a different private network, so a different VPC, and just make it so the first VPC can just call, that request to this VPC, and that VPC has no access to the previous one. And the moment you do that, it kind of like you're secure, that customers cannot abuse your internal network. And then from there, it just hits, the customer endpoints. So, and that's it. One other small thing that is important to think about, so that a lot of people neglect, is that if you're making, like if your customers are enterprise or like large organizations, oftentimes they would have, like stronger or more stringent security policies that will require them to have a firewall. and to only allow HTTP requests from like a static set of IPs. And so it's very much important to only send webhooks from a specific set of IPs, so they, they're able to allow it on their side and like allow it onto their firewall. And that's another reason why just sending from this like one set of predefined proxies is so much important. It's so important.
Is that like a business requirement that customers are going to have?
Yeah, I mean, sometimes just your customers may have may have firewalls, and they may need to know which IP addresses to allow just because of their organizational policies, and they will not be able to listen to your webhooks if you don't send them for a specific set of IPs.
Okay, that makes sense. It feels to me like most of these considerations are really about being able to scale. So like with a lot of the database stuff, right? Making sure that things aren't getting clogged anywhere, right? Everything's flowing nicely. And then secondly, to make sure that like the customers have a good experience, right? So when things go wrong, it's easier for them to be able to actually identify what went wrong and to fix it, essentially.
Yeah, exactly. That's like you always want your customers happy, and you always want your team happy. So you don't want to make it, like a maintenance hell for them. So you want to make sure that the systems just like work and scale automatically, etc.
So Tom, thanks for covering like the infrastructure side of things. Like, is there something else that people should know about like the features that they should be implementing? Like, what is the actual like user experience that this infrastructure is enabling?
Yeah. Okay. So I mean, one thing that we already briefly touched was retries. You want to make sure that you try. I mentioned the exponential backoff, but like want to make delivery is paramount. Deliverability is paramount. Sorry, and you want to make sure that the webhooks get where they need to get to. So you need to have like a robust retry mechanism in place. And you also want to know yourself when a delivery failed. Like maybe you tried delivering a webhook for 10 times, 12 times, 15 times, and it just failed, and you exhausted your retry schedule. You want to be notified of that in order to be able to notify the user. And what we do is we send you a webhook ourselves to your systems. If it's your own system, you can probably like send a webhook to your own internal like microservice, or just like query the database occasionally and send an email. I don't know, whatever works best in your scenario. And the other aspect to it is also, like as I said, like most services send a lot of webhooks, and most customers only care about a subset of this webhook, of these webhooks. So one thing that is very common that most webhook systems have is filtering by event type. So event types are essentially a way of saying, this is what this event is about. So this one is about a user being created, or this one is about a user being deleted. And this is the schema that is associated with that event. So kind of like your customers know exactly what to expect. And also, like as part of the system, they need to be able to say, well, I only care about user created and user deleted. I don't care about user modified. Or whatever, so they can filter the amount of webhooks that they receive. This will ease the load on your system, but also on theirs. And the other thing is, that we support, which, I think is important, but maybe not essential depending on your scale, is that we let you rate limit, the webhooks you send to your customers. So oftentimes, like our customers, we send us like a lot of webhooks per second, like, multiple thousands, all meant to go to the same customer. For us, it's not a problem. Like we're a scalable API company, like we can deal with this load. But the problem is that their customer is running like a tiny system with a tiny database, and they are not equipped to deal with that. So essentially like killing their system completely. Their system is like going to be like, the resources are going to get exhausted, and then you're going to retry again. And that will also kill the, like kill them even further. And you're just going to like, DOS them for like a while. And so we just let our customer define a rate limit and just say like, okay, I don't want to get more than 10 requests per second. And we are going to we're going to absorb the load and like kind of like unwind it for them. And then you have like a few other nice to haves that we do. I mean, for example, if you have a customer like that's responding to us with like a 429, so like too many requests, which like implies they're either, like loaded on their own, they just want to like rate limit us or like everyone else, or they just want to rate limit us because we're overdoing it. We actually respect that and add, and kind of like add another smoothing layer on our own. And I think this is something that more webhook systems should do, just like be a better netizen and like, interact between services like in a nicer way. Does that answer your question, Ken?
Yeah, I mean, I think the only other question that I might have, right, that I can think of, like
Yeah.
when you're starting out, like let's say you just got this, request that, hey, like we need webhooks, right? And you're like, okay, like I need to design this system. Like what is the first thing that you're going to end up doing? Like I would assume the first thing that you need to do is essentially like kind of define your requirements, right?
Yeah.
First, in terms of like what the system needs to enable. So like, do you have like a quick like kind of like hit list of like here are like the 5, 6, 7 things that it needs to do?
Yeah, so this is going to be subjective, right? But
Mhm.
I think that webhook systems that don't have it are at a great disadvantage. First thing, retries. The whole point is I need to be able to trust it, so I need to know that it's going to be delivered. If you only try once, that sucks, and your customers cannot rely on it. Second thing, security, always important. Make sure that you sign the request so I know it actually came from you. Sign the timestamp as well, so I know, there's no like replay attack or anything else. Another thing is like fan out. I want to be able to add multiple webhook URLs. I want to, maybe one is going to hit Zapier and one is going to hit Slack and one is going to hit my main system and one is going to hit my accounting system. I don't know. I want to be able to just like, direct traffic to multiple directions. Otherwise, I would just have to spin up my own server that does that, which is a bit annoying. And as I said, like filtering by event types, I think is very important. Because first of all, it forces you to be diligent about defining the schemas and the events that you send, because it is an API after all. So you need to define it and have it consistent. And then the other aspect of it is just like being able to filter by them, so you can reduce the load. Your customers can reduce the load and really only listen to the 1 or 2 events that they care about rather than the 50 others that they don't. I think those would be probably like my top. Oh, and one last thing, obviously, visibility. I wanna, as your customer, I wanna be able to see, did a webhook get here? Or like, why did it fail? And what was the response? Like all of that all of that information is like very important.
Okay. All right. Well, thanks, Tom.
Yeah, thank you.
I think that's a pretty good overview of kind of like our system, how it works, and like what it's trying to do, right? Like to enable all these features to make sure that if something goes wrong, your customer knows, and it can get fixed, and to just make sure everything's kind of just like running smoothly at scale.
Yeah, exactly.
All right. Thanks, Tom. See you.
Thank you. Bye-bye.